just looking at what is statistic and what is data handling. So data handling or statistics, that's really all about information, gathering information around a specific question that you're wondering about, something that you're investigating, and it's looking at that data, analyzing it, coming to some sort of a conclusion around the question that you ask. But it always starts with a question. So data is information. So information can be presented in a number of ways, in charts, tables, graphs, anything that you might have seen lately in books or on the television, on the internet, in newspapers. It really is everywhere around us. Okay. So it's especially if you're reading things with information and stuff, it's often just like everywhere. Okay. Now, data, and remember, you're welcome to take screenshots as we go through this. We have different kinds of data or different types of data. So let's look at this type of data. There's weight, there's shoe size, hair color, age, favorite food, height, and number of siblings. Now, all of those, they're not all the same, is it? Like, if you look at the number of siblings versus height, they can be represented in numbers, but the numbers are a little bit different. And when you look at favorite food and hair color, we normally describe those in words, not really in numbers. Okay. So the first sort of way that we categorize data or sorting data into different groups is to ask, is it numerical? So if it is numerical, then we say it is quantitative. If it is not numerical, it is qualitative. So our hair color and our favorite food, those are things that you normally describe with words. Like I said, like favorite food could be like a hamburger or pasta or pizza, and hair colors like brown, black, blonde, etc. So that is qualitative data. And then quantitative data is data that deals with measurements. So if you've got like height, weight, shoe size, age, number of siblings, that all has to do with measurements, something that can be measured in a way. So we first make those two sort of distinctions between different types of data. Is it qualitative or is it quantitative? And then if we have quantitative data, there's another distinction we make, and we call it discrete data and continuous data. Now, discrete data on the left-hand side with the number of siblings and the shoe size, that cannot be made more precise. It is usually in integers. So think of shoe size. Shoe size can only be like a very specific value. Like a 5, my shoe size is a 5, and a 7 and an 11. Yes, you get half sizes in shoes as well, but it's still very specific, and it indicates more, it's more about the shoe size than actually measuring anything. And then number of siblings, you can only have like whole numbers of siblings, right? You can have 1, 2, 3, maybe someone's got 11 siblings, I don't know, but you can't have like 2,8 siblings, okay? Because humans do not come in parts. We only come in whole numbers. Okay, so that's for discrete data. And then on the other side of that is continuous data. So continuous data can be any number, and especially decimals. We can measure it with any numbers. Decimals, like think of weight. Weight can be measured in decimals. Age, you can be 12 3/4 or 12 years old and a half, for instance. And then height can also be measured, and think of it, it's mostly things that can be measured that involve decimals. Okay, so give me a thumbs up or a thumbs down If you are happy with those types of data, Monica, you've got a question. You have your hand up. Yes, Monica.
Ma'am, can you please go up so I can take a screenshot?
Okay, which one?
Yes, ma'am, that one. Thank you.
Okay. Yo, guys, don't be afraid to take screenshots. Okay, so this thing, we are mostly going to focus on this thing with the yes, Tandalweta. If you see continuous, it's decimals, okay? So we're mostly going to focus on this distinction between the discrete and continuous. Okay, so now we're going to run a little experiment. And this is because I want to know more about the different eye colors in the grade 10 Watobe class. So Ms. Coco is going to launch our poll, and I want you to indicate on the poll your eye color, because no, not that one.
Oh, ma'am, we don't have high color here. We only have the height one here.
Do we
I'm
only
not
have the
seeing
heights?
Yes, ma'am.
Oh, okay. Okay, let's do the height one. It's fine.
Okay, sure.
Okay, so we're just going to change this to
Sure, ma'am, it's proving to be tricky. I think I may have closed it. I don't know what I did.
Can I try? Polls.
Yes, please. Yes, please, ma'am, if you can.
Okay. Relaunch poll. Continue.
Oh, there we go.
There we go. Everyone. Okay,
much
so
better
we
at
are
this than I am. Thank you.
so we are going to do height instead of eye color. So if you don't know your precise height, just indicate more or less. I wonder if we'll have an outlier here with Monica being the goal shooter.
I think I do see one outlier. I think someone is oh no, okay, no, because there was one person who voted for 0 to 145.
But there's three. There's three who
yeah,
voted for
three
that.
now, but nobody's taller than 190. So yeah.
Okay, so some people are saying they can't see the poll. Okay, everyone else, please participate. We want to see what the poll results are for this class. So for 53, we have about 10 more people that need to vote. What is your height? Just more or less. Spoiler. Kitwa says they can't see the poll, unfortunately. Yeah, look, don't panic if you can't see it. It's just a little class activity that we are doing. Okay, so let's leave this up for a second. And what have we got here? It looks like, so we've asked this question. We've collected our data by using this online poll, and it's giving us this sort of bar graph, I'd say, showing how many people in each category. So we do have one between 190 and 199, and then there's 4 people between 180. So there's about 5 people in the class that's almost 2 meters tall. Now, I don't know, Ms. Coco, because I mean, Ibn Etzebet is almost 2.04, I think. So some of these grade 10s are about as tall as Ibn Etzebet.
So just basketball players just everywhere. You guys should just
Yes.
play basketball. Yeah.
Oh, it's Quran who's so tall. 190 to 199. Yo. So that must be your, if not a lock in the rugby team, then definitely a basketball player. Okay, so we're now just going about basically analyzing our data. So second of all, what kind of data is this? Is it discrete or continuous? Can anyone post in the chat for me? Discrete or continuous data? We are working with height. Who's been listening? Continuous. Does anyone say anything else? Continuous, discrete. Okay, so let's think about it. We are measuring height. Height can be any decimal number, so it is continuous. It's not just a specific value like a shoe size or an eye color or something like that. It can be a range of values with decimal numbers in it. Okay. Now, what is the most common height? The most common height is 150 to 159, and a close second is 160 to 169. Now, can we calculate the mean height? Now, that is a question we are going to reserve for the next lesson, and I am going to take a snapshot of this poll results so that we can calculate the mean next time we are going to do in our next lesson. Okay, because we can calculate the mean, but it is a little bit different, and some of you who have done it in school will know about the estimated mean already. So we are going to do an estimated mean calculation with our own class heights on Thursday. Okay, but for now, let's move on to the mean, the mode, the median, and the range. And you're welcome to take a screenshot of this as well. So the mode, that is, when we look at a set of data values, the mode is the most frequent value. So you can think of mode and most. It's the number that occurs the most. Now, your data should always be arranged from smallest to biggest if you are doing the mode and the median and the range, etc. Especially for the median, it has to be arranged from smallest to biggest. Now, the mean is the average. So say you are you have written a few maths tests and you want to calculate the average of your tests. Then you'll take all of those test values, add it together, and divide it by how many tests there are. So our data set, as we call it, is 2, 2, 5, 6, 7, 8. So 2 plus 2 plus 5 plus 6 plus 7 plus 8, that gives me the 30, and I'll take that 30 and divide it by 6 because there's 6 data values, and my mean is 5 over here. The range is the highest number minus the smallest number. So that just gives you the range of the data. And then the median is the middle value. Now I do want to, so in this example, we've got 2, 2, 5, 6, 7, 8, 9. There is 7 data values. So it's easy to locate the 6 as the center value, the one that's in the middle. But if we have an even number of data values, 2, 2, oh, I've left out the 5, 2, 2, 5, 6, 7, and 8, then we have to go about it a bit differently. So this is for an uneven number of data values. But if you have an even number of data values, like here we've got 1, 2, 3, 4, 5, 6 data values, Then we have to take the middle two data values, 5 plus 6, and divide it by 2 to get the median. So that you only do if you have an even number of data values. So that's 11 divided by 2. That gives me 5,5. Okay. Just give me a thumbs up, thumbs down in the chat if you are happy with the mean, the mode, the median, and the range so far. Okay, lots of thumbs up. Shiraz is just typing thumbs up. Okay. Guys, we are about 68 people in the class, and I would really like all of you to participate and post your emojis in the chat when we ask to, etc. Okay, so don't hold back, participate. Remember what I said in the beginning.
Right. Ma'am, Lando is asking if you could explain the range, please.
Okay, so the range is just the highest value minus the lowest value. So highest value minus lowest. So here it's the 8 minus the 2, and that's 6. So that's the range. Okay, good stuff, everyone. Let's go on to this question where we've got Lucy's closet. Just want to move this a little bit. Okay, lovely Lucy's ladies wear. Okay, so Lucy has a beautiful shop in town that sells all kinds of ladies' clothing, colorful blouses, pretty dresses, tailored trousers, etc. Tandalwetu, we are doing another example now, so just to have another listen. Okay, we're all going to go through it again. So she's not very good at calculating her sales, always makes mistakes. So she needs your help. Calculate the mean, median, mode, and range of the following sales. Okay. So I'm going to give you 3 minutes to do this one. Here's the Monday dress sales. Calculate the mean, the median, mode, and the range. And don't forget, you have to put the numbers in ascending order. You have until past to do this. Hold your answers. Don't post your answers yet. I'll call for the answers and then we'll compare notes. Okay. Just hold your answer, everybody. Don't post answers yet. At about past, we're going to check in and check answers. Right, everyone, let's see. First, you had to rearrange your data from smallest to biggest. This is a key step. You cannot skip this step if you want to find the median accurately. So what is the average price paid for the mean? Post the answer in the chat if you have it. Just the mean. Remember, we are adding everything up and then we are dividing by 9, I think it is. And I think it's 43, everyone. Yeah, good stuff if you got it. What is the median? The median, we are going to look for the middle value. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 data values. The one that is going to be in the middle is this one here, 41. And the way that you can do it as well is to just use your fingers, start counting from the two sides, from 39 to 50, move into the middle, and you'll locate the median in the middle. And then what is the most common? I think we can all tell that it is 40. And then what is the range of the prices paid? The range, pop it in the chat if you've got it. The range, we take the highest value minus the lowest value, and that is 11. Okay, excellent stuff, everyone. That's good. Good work. So let's move on, because these three values tell us different things about the data, and sometimes we need to be careful how we interpret it. So, and you're welcome also take a screenshot of this, because this tells you the different sort of advantages and disadvantages of each of these measures. So the mean takes all values into account when you calculate it, and that's a really good thing, because you're not leaving any values out. Like for instance, the mode, it's the middle, it's really just the middle value that you're looking at. Oh, sorry, the median is the middle value that you're looking at. But the mean includes all data values. So, but the sort of disadvantage of that is that it is affected by very small and very large values, and we sometimes call those values outliers. So if we had a data set with some numbers in it, and there was suddenly like a really small or a really large value in the data set, we would call that an outlier. And that is going to affect your mean, right? Because if you add a big number to your mean, it's going to inflate your mean. It's going to make your mean much bigger. And the same with a small number, it's going to make your mean much smaller. So the mean is affected by very large and very small values. And then the median is not affected by very large or very small values. The median is the median, it's in the middle. But it is time consuming if you have a large number of observations or a large number of data values to rearrange them from small to big. So the ones that we've done so far, it's quite small data sets, but it is quite, if there's more data values, it is quite time consuming. Okay. Now the mode is the only one, it's the only average or measure of tendency that can be used if the data set is not in numbers, meaning it's qualitative. So if we did eye color, which is, if we looked at the eye color in this class, we, as opposed to height, so think of those two sort of data observations. Eye color, we can only look at the mode We can't really calculate the average eye color or anything like that. We can only look at what is the most frequent eye color recorded. But with the height, we can do the mean and we can do the median because it is a numbers-based data value. There can be more than one mode, which is a bit of a drawback sometimes. And there can also be no mode. And then, yeah, you can't really tell much from the data because there is no mode. All right. So in grade 10, you need to know these things about the mean, the median, and the mode, and what they mean and how effective they are, and how to use them. So let's do a quick example. Let's use this one here. So here are the exam scores of 10 students. We're going to calculate the mean score in question 1. Let's do that first. Before we go further, let's just calculate the mean score. I think we are all very good at using our calculator. We're just going to add up and divide by 10. So the mean score, 76 plus 63 divided by 10. Everyone's getting 64.4. A few more. Come, everyone. Let's get this over the line with the mean. So even though there is a data value of 0, we still count that data value. Someone got 0 for their exam. Poor person. No one here is going to get 0 for the exam. Okay, and that gives me 64.4. Yes, ma'am. Okay, now we have to do the median. Exactly. Or maybe they went to the wrong exam. Okay, so let's do the median. The median, we have to again, Tandalwetu, I think you have to just go back and check your median. I don't think that is right. So just rearrange your data from smallest to biggest. So we start with the 0. And what comes next is the 47. See, this is what is tedious about the median. You have to go through this process of rearranging. And then if there's like 20 or 30 data values, you can easily make a mistake. That's 63. And then this is 71. And then 76. The Watobians are quick, Ms. Coco. Gosh, some of them got it already. But I'm going to go slowly so that I don't make a mistake. 73.5, and that is 93. 93. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then the Watobians are saying it is 73.5. So we have to take the middle 2 values because there's an even number of data values. So 71 plus 76 divided by 2. 71 plus 76 divided by 2 is indeed 73.5. Well done. Yeah, Tandalwetu, I'm not a fan of those formulas because exactly that. You have to do the 5.5 value, and that still means that you have to add the 5th and the 6th value together and divide by 2. No, don't round, DNZ. Don't round up. It is 73.5. Why are we dividing by 2? Because we take the average of the middle 2 values. Okay, because we now have an even number of data values. That's why we divide by 2. We basically take the average to get the median. Okay, now which one of these is true? Explain which of these measures of central tendency. So central tendencies, mean, median, mode, those ones, better represents a typical score in the exam. So if you looked at your mean and you looked at your median, which of those gives you a very good idea of how these people scored on their exam? Shiraz says the mean. No, I know we don't divide by anything other than 2. We just divide by 2 because we take the average of those 2 values. There's 2 values, so we divide by 2. Okay, so which of these, the mean or the median, is better? Shiraz says the mean. Anyone else? Also, Emmanuel says the mean. Exactly. It considers all data values, but remember, it also is affected by very small and very large data values. So would this mean not be affected by this very small data value, which is the 0? The 0 is what we call an outlier. Remember, guys, I said here, if there's a very small data value, it affects the mean. And in our data set, we've got a very small data value. We've got the 0 here. So now some of you are changing your minds and you're saying it's the median. So in the chat, put an option A, B, C, D. Read carefully what it says. Which one do you think? Is it A, B, C, or D? Remember, the median is not affected by outliers. I'm going to agree with some of you who are saying A. It is option A. The median, because the mean is skewed too low due to the score of 0. Okay, so that is going to be our best measure of a typical score in this exam. Okay, so not a good idea to use the mean because of that 0, and because of the 93, I wouldn't say is such a problem, but the 0 definitely is. Okay. Because the median, Anu, is not affected by really small values. So if we go back to our notes here, the mean is, and we have that 0 data value, so that is skewing the mean, but the median is not affected by very large or very small values. So that's why we're rather going to use the median score as a measure of a typical score on this exam. Okay. Right, let's move on to something a little bit more, it's going to make us think a little bit. Oh, someone is still asking why not B? The median, because the mean is skewed too high due to the score of 93. Because the 93 is not a problem. It's not that high. It doesn't have that much of an effect on the mean. It's the 0 that's the problem, because it's 0 and then the next value after that is 47. So the 93 is not that far away from the 82 and the 81, etc. So that's why we don't think it's B. Okay. Right. Let's do a little thinking question here. Just calculating the mean. Okay. So the mean of 4 numbers is 5. Given that one of the numbers is 8, what is the mean of the other 3 numbers? Let's think. The mean of 4 numbers is 5. Given that one of the numbers is 8, what is the mean of the other 3 numbers? Does anyone have any ideas that they want to share? Put your hand up if you have any ideas about how we can calculate this question. Come, Shiraz, try. Let's try something. Okay, Emmanuel, let's hear.
Hi, ma'am.
Yes.
Ma'am, here's my idea, ma'am. So isn't it, it says the mean of 4 numbers is 5, ma'am. So I times 4 times 5 and I got 20. Then I minused it by 8. Then I got 12, ma'am. Then I divided 12 by 3 and I got 4. That's my guess, ma'am.
Very nicely done, Emmanuel.
Thank you,
Okay.
ma'am.
So this is what Emmanuel said he did. He took the 4 numbers for the mean. The 4 numbers is 5. So we know that we always take whatever those numbers add up to and divide it by the number of values we have. So we know we're going to divide by 4. So he said if the mean is 5, then we go 5 times 4, and that is 20. So whatever those numbers are, whatever those 4 numbers are, they must add up to 20. We know that one of those numbers is 8. So then he said, okay, subtract from the 20, the 8, and then you get 12. So the question asks, what is the mean of the other 3 numbers? So it's not asking you specifically what the 3 numbers are, just what the mean is. So we can take the 12 and divide that by 3 and get 4. So that's the mean of the remaining 3 numbers. Okay, let's try another one. Here we go. Number 2, the mean of 5 numbers is 3. Given that one of the numbers is 3, what is the mean of the other 4 numbers? Come, now we know. Could easily come up in your exam, Bonolo, because this is just asking it a little bit differently, especially as a challenge or as a problem-solving question. And this class, I know, loves a challenge. Oh, so now the answers are streaming in. Everyone's saying it's 3. I wonder if someone wants to tell us how they did it. So the mean of 5 numbers is 3. So we are going to go 5 times 3 again. That's 15. One of those numbers is 3. So we subtract it, and that's 12. And then we go 12 divided by 4, and that gives me 3. Okay. Anu, just check. You should get 3. Okay, let's do this last one with the football. No, it's Yamu. Try this one. Try this one. This is your one. The football team plays 4 games. The mean number of goals scored in these games is 6. After the next game, the mean number of goals scored drops to 5. How many goals were scored in the 5th game? Ha! Another one. Let's see. You can think of the answer. Sandal, we mustn't rely too much on formula. Let's just rely on our logic and our ability to solve problems. Because most problems in maths don't have a set formula. This is just working backwards, basically. It's like when you have the mean and then you work backwards. Okay. Who wants to volunteer their answer for us for question 4 with the football team? You can go to school tomorrow and feel ready for any challenge that's going to come your way. Those hard questions that come up in exams, not a problem. I think we should get a whole number because it's goals scored. You can't score part of a goal.
Guys, I'm loving how your answers come with like sad faces and crying faces.
I don't know why.
And then like there's a face palm. Guys, what's going on? Are you guys okay? Are you guys okay?
Are you okay? Okay, let's see. So we're going to take, the answer is actually 1. So we're going to take 4 times 6 because that is how many they score now. The mean number of goals scored is 6. So in the 4 games, we times it by 6. So that gives us 24. After the next game, why did you, I'm just reading the message. I don't know, Shiraz, I heard so many answers, sorry. But you're right, the answer is 1. After the next game, the mean number of goals scored drops to 5. So in 5 games, they score 5, the mean is 5. So now we times that by 5, that's 25. And then we work out the difference between the 2 numbers, and that's 1. I'm going to leave it there for this evening. 4 games, 6 goals, 5 games, 5 goals. Oh.